Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. I'm your host for the show, Matt Picardal, and in this episode, we'll be talking with Geoff Smith, a senior associate at Silman. Geoff was also a co-host on our This Week in Civil Engineering show, and in this episode, we'll be talking to him about the process of existing building renovations and how teamwork plays a major role in these types of projects. Now, let's jump into our conversation of the week.
This episode of the Structural Engineering Channel is brought to you by PPI, a leader in engineering exam prep for the PE structural exam. PPI provides expert prep courses and study resources designed to help you pass the PE structural exam the first time. PPI's PE structural course is fully updated and taught with October 2021 code references and includes new editions of their PE structural books. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. When you take a live online course, PPI guarantees you will pass, or you can take the on-demand course for free. PPI has helped engineers achieve their licensing goals since 1975. Check out PPI today at PPI2pass.com to see all of the resources available for PE structural exam prep. Again, that's PPI2pass.com.
Geoff, welcome to the show. We're delighted to have you with us today. For those of our listeners who might not know, can you briefly introduce yourself and tell them about what you do on a daily basis?
Sure. My name is Geoff Smith, and I work at Silman out of New York City. On a daily basis, generally, we collaborate with architects and other design professionals to make things stand up.
Awesome. And we want to talk about existing buildings today. So that's a really interesting topic. In my career, I found, at least with structural engineering, there's new building design, there's existing building design, and two different, I'd say really different in terms of the problem solving aspects, really different sets of problems. So can you explain what it's meant by the word existing buildings, and how can existing buildings be sustainable, since that's something that's really relevant today?
Sure. The biggest thing is that an existing building is already there. Like that's essentially what an existing building is it's already a structure that's built, and how we can work with that existing building is really beneficial for the built environment in terms of carbon footprint and any kind of green technology that we're dealing with, because we don't want to actually demolish any structures to build back new structures that just take up more of a carbon footprint than anything.
Yeah, that makes sense with because there's the cost to tearing down a building, and then there's more cost to making a new building versus, hey, what can we do with this existing structure? How do you get to that decision-making process? I'm assuming with the building owners and whatnot.
Right.
Where's that decision made? I'm sure cost-wise on it's going to be a retrofit versus, okay, it's going to be a new building.
So out of New York City, we don't have much open space here. So a lot of it is retrofits to start. Like you have some demolished buildings that then get essentially new towers or something like that put back in its place. But if you have a facility already there and a building already there, and if we can determine that the bones can hold up what the program is for the structure that the owner wants, we tend to, at Silman, we push to renovate the building, just because that existing building has a value, right? Both monetarily and socially. So with keeping that existing building in place and modifying it in some way, you're helping the environment and you're helping the owner achieve what they're looking to achieve with that building as well.
Yeah, and it's is it almost always if you keep a building, it's going to be better sustainable for the for the carbon footprint? Is that almost always the case in terms of sustainability?
I would find it rare that it's not the case. Right. Like, so because if you're demoing a building to put a new building back in its place, you're hitting it, you're hitting the carbon footprint in the environment twice with that, because you then have to get rid of the material that you're demoing, and then you have to manufacture the material that you're putting back in its place as well.
Yeah, that makes sense. What about a probe campaign? I've heard of that, but what is that, and how does it affect the renovation process?
So a probe campaign is when we go into an existing building and we take down the finishes and get to the actual structure itself. So like all of the drywall, the ceilings, any fixtures or things like that that happen to be in the way, to remove that and actually get our full eyes on the bones of the building and the structure itself. Sometimes we have existing building drawings, which are great to have. But even when we have those, we still go through a probe campaign where we will open the building up just to verify that those existing drawings are accurate. Because there has been so many times where we go in with a full set of drawings and they're completely wrong.
Mm-hmm.
Or like modifications have taken place from that original space. So you can see kind of where, like, say where a steel beam has been cut and a new steel beam has been installed. And you would never have found that unless you did a series of probes inside the building. To just popping up the ceiling itself to look around is beneficial.
Yeah,
like if you have a dropped ceiling space.
Yeah, it's rare to have the existing building drawings, but even when you do have them, you go in, especially with those older buildings. What? Wait, these drawings are useless.
Yeah. Well, they're a starting point. They're not useless. They're a starting point of where things went wrong.
It's like, where did this mezzanine come from? I remember doing one for one of our buildings. Like, wait, there's this whole mezzanine. Where is this on the drawings? And then it's a good starting point. But that's when you do the probe campaign and you're like, oh, this is what it's really like, because there's not that many as-built drawings, and sometimes, who knows, they might have gotten there without a permit or documents lost and whatnot.
Yeah, or the owners simply don't have them, right?
Mm-hmm.
Like they may not have existing drawings at all. And then there's a whole risk factor to the owner if you go in with just broad assumptions. Like, you may say, what is the owner willing to accept as a risk without knowing exactly what's there for the structure? And then that comes back in construction administration when you open it up and you're like, oh no, we need to fix it. The contractor's already on board, steel's already fabricated, or something, or timber's already bought. Like, there's levels of risk that probes tend to eliminate, or try to. Like, you're never going to eliminate all risk. So that's.
Mm-hmm. And for the pro campaigns, at least the way over there in New York area, is it just hey, we're going to tear open the soffit, or is it, hey, we're going to tear open a lot of things and see what the actual structure is, or what's the extent of that?
So we usually go for like corners, right?
Mm.
Corners of spaces, so that you get connections, so that you can see the connections, and so that you can get more bang for your buck in terms of, like, you open one probe, but you can see the column, you can see the girder, and you can see the infill beam all in one space. And then you can kind of trace those out as you go. So it's picking spots to go to and open those up, key spots that help you with that.
And then, during construction administration, that's
it
when
all opens.
That's when you really
you verify your assumptions during that.
What about the existing building history? How do you get that, and how do you review that?
So that comes from, when the building was built, right? And then coming with the knowledge of the construction of that era. And where that actually feeds into where we do probes. Because if you know that it's a flat plate building with concrete girders, you're not going to do many probes, because you're not going to find out anything unless you're going deep into opening up to find out rebar and things like that. But we have some terracotta flat arch slabs here in New York City, which are not common anywhere. Yeah. So we also have, it's called a drape mesh slab here, which is, it's a catenary system where the slab is just fireproofing, and it's actually this welded wire mesh that provides the structural system. But if you don't know the history of the building, you're not going to know that. And if you don't know the construction methodology that was used at the time, you're not going to know that either. Now, there are ways to find that out. There are books, there are a bunch of different articles and things like that will help you with that. But there are, without knowing kind of the history, you don't know where to start.
So it's figuring out what the structural system is, and some of those structural systems are very outdated or not used, and then you just gotta do the research and see what the strength is of those,
right,
or how those things work.
Yeah, and we use we use a bunch of finite element models to verify that they still do work, right? Like you got if you're changing loads in the building, you have to verify. So we're working on a building that's a slag block slab, which is essentially a giant waffle slab where they put these giant cinder blocks in the formwork to minimize how much concrete went in. So it's just a waffle slab that has a small, thin slab over the top that connects all the waffles together.
And then you got to do some type of analysis to make sure that this old material or this old structure still works. Yeah, that's one of the challenges of existing buildings that I've seen.
Yeah.
And
no, and then there's like the grades of the steel and the concrete and the strength of it that you have to determine too. So whether that's laboratory testing that you do with coupons, the concrete itself, whether you take cylinders.
So before you do all your analysis, sometimes you might have to do that, doing some cores, see what the actual strength of that old terracotta is and the steel. That's interesting. Yeah. But what is it like in terms of working with different governmental agencies? I know you've worked with different size organizations and different types of projects throughout your career. What's that like working particularly with the government over there, and maybe the existing building departments in that?
Yeah, no. So when we do a renovation, because in New York City there's a lot of subterranean items, whether it be Metro North trains, Long Island Railroad trains, the subway itself, we have to submit our drawings to them for review, and they have a very specific requirements as to what they want to see on the drawings themselves, and those reviews can take some time. So if you have a building that's right next to a subway line, like it's going to be a little bit longer to get that through the permitting process, because then it has to go through the MTA, the New York City MTA, and get through all that process of the internal reviewers and everything else. They just want to make sure that you're not putting undue load onto their structures that are 100 years old. So
makes sense.
But it's the right thing to do. If you're changing load, you want to make sure that nothing's going to happen to the subway.
Yeah, but I could also imagine that was it more eyes on the project and probably more delays, and talking with the plan checkers and the agencies on trying to show that, hey, it's going to be okay. So it's more of the government process that you have to go through. Yeah,
it's like a buildings department review plus. Basically,
plus,
and then like another plus on top of that. So that's kind of what it goes to.
Yeah, that's something that I haven't had too much experience with. I think at least in my projects, they're usually, well, I guess we'll run into conduits and things like that. But talking to structural engineers from the New York area and where there's a lot of subways, that's a whole can of worms sometimes. Where we got a subway under here. What are we gonna do? What are we gonna do? You don't know what you're gonna pull up.
That's when you use the gymnastics that we have in our toolbox, right? Where we're dealing with cantilevers and backspans, and sometimes you have to cantilever over top of a tunnel, and it gets funky. It gets pretty crazy.
I can imagine all the structural gymnastics that you have to go through to avoid surcharging. Yeah, especially those older subways.
Yeah,
and I know you've been on a lot of teams. For you and your experience, what makes a good collaborative team, and how does it affect the projects that you work on?
So number one is actually buy-in from the entire, both design team and construction team. So if you have a team that's all together working on the project and not combative with one another, it makes the project go so much smoother and so much faster for everyone, both the contractor, the owner, the architect, our team, the structural engineers, because we're working together. If it becomes combative, which you hate to see, where it's like, you didn't do this, you didn't do this, that tends to make things go sideways, frankly. Then everybody gets defensive, and that's not good for a collaborative process.
And that takes everyone being on the same page. Like you were saying, with the different disciplines, I think getting the expectations straight from everybody, because everyone has different responsibilities, and if you guys can get all on the same page, that makes it a lot better.
Yes.
But I'm guessing that's how you would want to work with team members that know renovation and what it takes, right? In terms of working with someone that's never done it before, and they might get surprised.
Well, I'm not saying we haven't, because we have worked with people who've never done renovations before, and it's just, if they come in with the collaborative mindset, it's much easier, because then they're willing to listen to what knowledge you have and you're bringing in from your experiences, both whether it's the contractor and our team with an architect who has not done a renovation before, or whether it's the design team doing it with a contractor that doesn't typically do renovations. It helps if we're all willing to listen to one another.
And how do you manage and improve team dynamics over the long term? I'm guessing it's great if they're all collaborative, but are there ways when maybe they're not so collaborative, and maybe we can, let's try to help them out?
Face-to-face meetings are generally the best, right? Like you can get into issues over email, where you're just emailing to an email, and if you don't recognize that that's a person, like that you're emailing and they're emailing back to you, things can get skewed and get pretty nasty pretty fast. But if you have a conversation with a person on site or in a meeting, it really helps. And it helps to see that they're actually people, right? Like there's, and it sounds a little cliche, but just going out to lunch with the team or having a team dinner helps with that collaboration, because everybody sees that everybody's not just a structural engineer, an architect, a contractor. Like they're people too behind that.
Yeah, it's a team, and I think more with the, I don't know, the texting or the messaging that's kind of been more prevalent in the last couple of years. I think that has its place, definitely, but
yes,
that phone call or even just meeting in person, I think maybe an email that could seem really, I don't know, aggressive or misinterpretive. And then all it takes is sometimes just a phone call. Oh no, XYZ, and this is the reason why. Like, oh, okay.
Completely agreed.
Exactly.
Yeah. Phone calls solve so many things, and sometimes people just don't pick up the phone, and that us too, right? Like there's times where you just want to avoid the phone, but there's times to use it and just say, hey, what's going on?
Yeah, those teaching the new engineers. Okay, if there's like one or two back and forths, let's pick up the phone,
right?
Or let's. I'll just go over to your desk if you're in the office.
Yeah.
Oh, okay. This is what you meant. Got it. Yeah, because it's kind of like that communication. I know some folks like to just call and pick up the phone, but I think some of the younger engineers are more used to that communication, but showing everyone that, hey, there's times and places for when you should pick up the phone and when you shouldn't, because it could save a lot of time and a lot of misinterpretation.
Completely agreed. I think that's one of the biggest things that younger engineers can learn from.
Yeah, and it's like the workplace, especially if it's the first time. All right, this is how you communicate, guys. I'm not teaching this in school. Geoff, to end off here, do you have any final piece of career advice for structural engineers, either in their career or even in their building projects?
Sure. I mean, besides picking up the phone, right? That was the one.
Yeah.
Besides that, I think you always need to be willing to learn, right? Between materiality and technology, everything's always changing. So if you learn something well, don't be afraid to learn something else that comes along too. So your basic statics and dynamics are going to stay the same, but the materiality and the technology is always changing.
Yeah, I know the AEC industry is still kind of slow, I guess, overall, maybe compared to the tech industry or whatnot. But it's always changing, and especially with the computers and new technology, even from the manufacturers, encouraging them to try that stuff out, because that might be the future, or that's the new innovation. I think that's what we need in our industry: more innovation and questioning why we do things the way we do. So I think that's great advice.
No, thanks. So it was great talking to you, Matt.
Yeah, thanks, Geoff. Thanks so much for coming on and talking with us. Really appreciate it.
Yeah, no problem. And if you ever need me again, I'm here. So
absolutely. I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and/or questions. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of the key points discussed in today's episode, which is episode number 91, as well as links to any of the resources, websites, or books mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.